Hello students, welcome to today's lesson where we are going to look at electrostatic charging of objects by rubbing. Here we are going to start with some experiment. We are just going to elaborate where you are supposed to have a plastic cob or a plastic pen or rubber. Then you cut small pieces of paper and you place it on your table. You are supposed to rub the cob against your hair or sweater, and then you bring it closer to the small pieces of paper and observe what will happen. When you do that, you will find that this plastic cob or plastic pen will attract the small pieces of paper. This shows that the plastic cob has acquired some charges when rubbing. And these charges are the ones that is enabling that cob to attract those small pieces of paper. Another experiment is when you are wiping your household mirrors or windows. When you wipe your windows using a dry cloth, you always find that that window attracts dust. Or when you are removing a cloth, a nylon cloth, you find that sometimes you hear a clacking sound, or it is attached to your body and it becomes difficult for you to remove it. All these observations are as a result of what we call the formation of static charges. When we talk of the word static, it means that it is not moving. Those charges are stationary. Now, the charges are found on the surfaces of the material, and they are caused by friction between the rubbed materials. So when you are rubbing, there is friction, and that causes those charges. The materials are said to be charged, and the study of those static charges is what we call electrostatic. Therefore, in simpler terms, we can say that electrostatics is a branch of physics that deals with static electricity or static charges. And this static means that we are talking of non-moving charges, and those charges are on the surface of the object. We move to electrostatic charges of the material. We consider a rubber rod. When we rub a rubber rod against a woolen cloth, this rubber rod gains millions of electrons from the woolen cloth. Therefore, the cloth loses some electrons to the rod and it becomes positively charged, and the rubber becomes negatively charged. If you look at this, we are saying that the rubber has gained electrons, therefore it has become negatively charged, while the cloth has lost some electrons and therefore it has become positively charged. But when we have a glass rod and you rub it against fur, the glass rod loses electrons to the fur, and therefore it becomes positively charged and the fur becomes negatively charged. A body is said to be positively charged if it has excess of positive charges, or in other words, it has lost some electrons. A body, on the other hand, is said to be negatively charged if it has excess of electrons, or it has gained some electrons from another body. Therefore, the following materials becomes negatively charged by friction. 1, we have polythene, we have plastics, and ebonite. All this becomes negatively charged when rubbed. And the following becomes positively charged. We have acetate, perspex, glass or fur. This one becomes positively charged when they are rubbed. Then from there we move to types of charges. We have 2 types of charges. We have 1, positive charges, and this one is gained or it is obtained when an atom loses electrons. When it loses electrons, it will have more positive particles than negative particles. Therefore, it becomes positively charged. When we have negative charges, this one is obtained when an atom gains electrons. In other words, the electrons or the number of negatively charged particles will be more compared to the number of positive charged particles, and therefore that atom will be negatively charged. The SI unit of charge is coulomb, and the symbol is capital C. But we have other units that we use. We have millicoulombs, we have microcoulombs. We have the equivalents here. 1000 millicoulombs is equivalent to 1 coulomb. 1000 microcoulombs is equivalent to 1 millicoulombs, and 1 million microcoulombs is equivalent to 1 coulomb. So when a body has equal number of positive charges and negative charges, then that body is said to be neutral. In other words, we are saying if a body has equal number of protons, which are positively charged, and electrons, which are negatively charged, then that body is electrically neutral. We move to the basic law of electrostatic, and here we are supposed again to have an experiment where you are supposed to bring a positively charged body closer to another positively charged body. When you have those two, their charges are similar. You will find that they are going to repel. But when you have a positively charged body, you bring it closer to a negatively charged bodies. In other words, when you have charges that are not similar or unlike charges, then those two bodies are going to attract. Therefore, the basic law of electrostatic states that like charges repel while unlike charges attract. Then we move to the source of charge, and in here we are going to look at the definition of matter. From the particulate nature of matter, we found that matter is made up of atoms, and these atoms are ever in motion. So an atom has 3 other particles. We have protons, neutrons, and electrons. Now the protons and neutrons are at the center. They are concentrated in the small space of the center of the atom, and that space we call it the nucleus, as shown in this diagram. You can see that the protons, which are positively charged, are the center, and the neutrons have no charge, they are at the center. So because protons are positively charged and they are at the nucleus, then they make this nucleus to be positively charged. So protons are positive charges, electrons are negative charges, and neutrons do not have any charge, they are neutral. But as you can see, the electrons are at the energy levels. They are far away from the nucleus. So the number of protons and the number of neutrons and the number of electrons are equal. So if an atom has 11 electrons, it implies that it has 11 protons, 11 neutrons, and of course 11 electrons. Because the number of protons which are positively charged and the number of electrons which are negatively charged are equal, then that atom is said to be neutral. Electrons are always moving on orbit, that is the outermost energy levels. They are at the orbit, they are moving around the nucleus. Because they are far away from the nucleus, they are weakly held by that force of attraction. And that is why it is very simple, or it is possible to remove the electrons from the atom by just rubbing, because they are weakly held. Note that when we are rubbing, we are not destroying the charges, or we are not creating the charges. All what we are doing is that we are transferring the charges from one atom or from one material to the other. We cannot create, we cannot destroy charges. We just transfer them from one body to the other. A charged atom, whether it is positively or negatively charged, is called an ion. So when we charge, or when an atom loses electron, or when it gains electrons, it becomes charged, and therefore we call it an ion. Then from there we move to charging by contact and by induction. We start by induction, and we want to charge a polystyrene ball negatively by induction. We move to procedure number 1, where you're supposed to suspend our ball that is coated with aluminium using a dry silk thread. We are suspending it. Then we bring a positively charged glass rod close to but not touching the suspended ball. After bringing it close as shown here, you can see that the negatively charged particles will be attracted by the rod here, while the positively charged particles will be repelled. Then after that, you are supposed to touch the side of the ball away from the glass rod with the finger. So when you touch as shown, you will find that the electrons from the earth will come and neutralize the positive charges that are here. They are going to neutralize. In other words, the electrons from the earth and the positives on this side that were repelled, they will cancel one another, and we say that they are neutralized. All what is left is the negative charges in our ball. So, in other words, the ball becomes negatively charged. So when you remove the rod, the charges will redistribute and your ball will be negatively charged. Maybe you may ask yourself, why are these electrons moving from the earth to the ball? If you look at what we have here, these electrons or these negatively charged particles are strongly attracted by this glass rod. So these electrons are very difficult to move from this ball because they are held strongly by that force of attraction. But the electrons from the earth can move through your body, through your figure, and neutralize the positive charges that are here. So that way you are able to get the negative charges on your ball. When you remove this glass rod, the charges redistribute to your ball and the ball now becomes negatively charged. That way we say that the ball has been charged negatively by induction. Then we move to the second type of charges, that is by contact method. And here again we are going to suspend a polystyrene ball coated with aluminium using a dry silk skin or thread. Then bring a charged glass rod, here we are using the glass rod, close to but not touching the suspended ball. Bring a charged glass rod in contact with the ball, rolling it over and over again on the surface. Then withdraw the charged rod. We are saying that the first procedure, you have brought your glass rod close to, and as you can see, the negatively charged particles are attracted and the positively charged particles are repelled. Then after that, you roll over. This is procedure number 3. You are rolling it over. So as you roll it over, you are neutralizing the negative charges that were here. Remember, all the negative charges were attracted. Then finally, you are supposed to withdraw the charged rod. When you withdraw, the positively charged particles will redistribute and your rod or your ball will be positively charged. That is charging through the contact. So first of all, you are bringing it closer so that you can attract the negatively charged particles. Then you roll it over so that you can neutralize the negatively charged particles. And then finally, you withdraw your charged rod so that now the charges that are left can redistribute and your charged body can gain the positive charges. Note that when a positive charge rod or when a positively charged rod is rolled on the ball, some of the negative charges induced in the ball are neutralized. And these are neutralized by the positive charges on the rod. When the rod is withdrawn, the positive charges redistribute all over the surface of the rod, and therefore the rod has gained a positively charged. Know that when you are charging a body by contact method, it acquires charges that are similar to the ones on the charging rod. In other words, we are saying our charging rod was positive and our ball has gained positive charges. Therefore, the body or the charging rod and the body has acquired similar charges. Then from there we move to charging by separation. And in here we have two spheres. We have A and B. Then bring a charged polythene rod close to but not touching sphere A, as shown here. We have A and B. We have the charged polythene rod, which is negatively charged. When you bring it close but not touching, it will attract the positive charges. Remember, because these two were in contact, they are acting as one body. So all the positive charges will be attracted towards this head, and all the negative charged bodies will be repelled towards the other head. Then after that, you are supposed to move sphere B away so that we can break the contact. As shown here, we have moved sphere A away. So now the two bodies are not acting as one. Then after that, we are supposed to withdraw the charged rod and test the two spheres. You can test whether they are positively or negatively charged by using a negatively charged rod. As shown here, we have removed the rod, and now the charges in A has redistributed and the charges in B has redistributed. So A becomes positively charged and B becomes negatively charged. Then from there we have the assignment. And as you can see in this assignment, we are just testing what we have just learned. So make sure that you're able to get everything. The answers are provided. Some other answers, you are going to get them directly from your note. So read and revise before you attempt your assignment. So thank you, and let us meet in our next lesson.